Hello, this lesson is linear functions and it's from page 306 in your student book. Your objective is you'll be able to represent a linear function using the function tables and graphs. Your essential question is, how can I determine whether a set of data is continuous or discrete? So functions are just like equations in that they can be represented using a word, table, a graph, and as an ordered pair. So notice how we have been saying the function of x is, and then we have the rest of the equation, or the rest of the function, I should say, and it really is the same thing as just substituting y equals x plus 5. When it's in this form, it's called a function. In this form, it's called an equation, but you treat them both the same. All right, so the first word problem we're going to start with is, the school store sells book covers for $2 each and notebooks for $1. If you can only spend $5, how many book covers and notebooks can you buy? So you're really combining the book covers and the notebooks. And we haven't done one like this before, but our y variable is how many notebooks. Our x variable is how many book covers. So we'll start out by examining, well, what if we don't buy any book covers? So if we don't buy any book covers, you would substitute the 0 in for x. And so then you would just be able to buy $5 worth of notebooks. Here, well, then you say, well, what if I want to buy at least one book cover and the rest notebooks? You would say, well, then I can afford one notebook and 3 book covers. What if I want to buy 2 book covers, 2 book covers, I can afford 1 notebook. Last one, well, what if I want to buy 3 book covers? Well, then you wouldn't have enough because the book covers are $2 each, and so you would actually get a negative number. Then your book, or your work tonight will say to graph it, and graphing it you would just say, my x is my 0, so stay on the 0 and then go up to 5. So here represents 0 book covers and 5 notebooks. If you bought 1 book cover, you would get 3 notebooks. 2 book covers, you would get 1 notebook. And then obviously this one's off the graph, and so that I graphed it, but it really wouldn't be an option. All right, another word problem. You can have a repeating pattern of tiles, and each arrangement or pattern would have 6 triangles and 1 hexagon. How many of each tile do you need if you can use 35 tiles? So you would say my hexagons can equal my total minus 6 triangles. So I'll try to go a little faster here. If you have 1 hexagon, that will allow you enough for 29 triangles. If I have 2 hexagons, then I'll have enough for 23 triangles. If I have 3 hexagons in my pattern, that would have enough for 17 triangles. And then you keep going. Well, what if I have 4 hexagons? Then you'd only have enough patterns or tiles left to have 11 triangles. Same thing with graphing. You would say 1 is my x, so go over to the 1, and then when I graph these, I went by 5, so each cube or spot here represents 5, and so I went 1 hexagon, 29 triangles, 2 hexagons, 23 triangles, 3 hexagons, 17 triangles, and 4 hexagons, 11 triangles. All right, another vocabulary word, continuous data. It means data can be any value. So in this one, the graph's coordinates are connected with a line, and it's really saying, oh, I know it can be maybe a 2 and a 3 and a 4, but it can also be everything in between those whole numbers. So you think to yourself, according to my word problem, can I have a half of something or a third of something? If the answer can be any value in between, then you know it's a continuous data or continuous graph. Discrete data. Data on the graph will have gaps in between the coordinates. The graph is not, or the coordinates are not connected with a line. They're individual and stand alone as solutions to your equation. And so you'd ask yourself, well, in this particular situation or word problem, can I have 1.5 for an answer or 2.5 for an answer? Or can I only have the whole numbers that answer that equation? And you know it's discrete data. All right, sometimes you won't even have a word problem. You'll just have the directions that say graph y equals 2x plus 5. And in our previous lesson, you knew you could choose any x's. That's the same for this lesson as well. You'll be able to choose any numbers that you'd like to be for x. Then have your rule within your table. And then once you've solved it, then you can just graph -1, 3. So I went -1, 3, 0, 5. So stay on the 0, go up 5. 1, 7, go over 1, up 7. And the last one, 2, 9, go over 2, up 9. And that's the end of the video. Have a great weekend.